Hi, a pleasant day to everyone. Today, I would like to give a brief explanation about formulation and rheological properties of hand sanitizer in different dosage forms. Before I begin, I would like to introduce myself. I am Farah Nurhani, a second-year student from School of Pharmaceutical Science of University Science Malaysia. As we all know, water and soap is the most efficient way to remove pathogen from hands. However, if water and soaps are not available, what can we do? Today's topic is about hand sanitizer. Hand sanitizer is an option if water and soap is not available. Hand sanitizer or hand rub is defined as an agent that applied to the hands to remove common pathogens that cause diseases. There are two types of hand sanitizer, which is alcohol-based hand sanitizer and alcohol-free hand sanitizer. Alcohol-based hand sanitizer use high concentration of alcohol to remove the pathogen. The alcohol concentration must be above 60% in order to kill bacteria and viruses. The high concentration of alcohol kills the pathogen by destroying their cell wall and denature their protein. As for alcohol-free hand sanitizer, it uses benzalkonium chloride or benzalkonium chloride as its active ingredients. Thus, it is safer to use for children. However, both of the antiseptic can only reduce or suspend the growth of bacteria. Therefore, World Health Organization does not suggest to use it for fight COVID-19. Let's take a look at dosage form and rheological properties of hand sanitizer. Before that, I want to let you know the definition of rheology. Rheology is the study of the flow of matter and it involves time-dependent behavior with the influence of pressure. Hence, it is important to know the rheological properties of a dosage form. First, solution hand sanitizer. Solution or a liquid hand sanitizer is one of the dosage forms that is widely found throughout the market. It may come in a small container so it can fit in the pocket and use it when travel. It can be applied either by pouring or spraying directly to the hands. Some of the users may prefer this type of hand sanitizer because of its application. From the observation, solution hand sanitizer has Newtonian flow since it only needs a small force to flow. It can be concluded that there is no interaction between the ingredient. Therefore, the interaction is not strong enough to unable to prevent the liquid from flowing. It shows that the solution hand sanitizer has low viscosity and higher flowability. Next, a gel hand sanitizer. A gel is a water-based semi-solid type of liquid. It can be either transparent or translucent. Gel hand sanitizer is also one of the widely available hand sanitizer in the market. It also comes in a small or large container. Most of the application is by pump, but there's also a container that needs you to pour it in your hand. This kind of container requires the user to shake a bit or squeeze the container to take out the product. Gel hand sanitizer also is very easy to spread on the skin. Since it is in gel form, it can stay longer on the skin while the evaporation rate of alcohol is lower. The rheological properties of the gel formation can be described as non-Newtonian behavior. It is a pseudoplastic flow because when the stress is applied, the gel is still able to flow. Pseudoplastic fluid happens when the concentration of polymer molecules in the solution is higher compared to concentration of polymer in Newtonian fluids but lower in plastic fluids. Third, colloid hand sanitizer. A colloid is a substance that made up of system particles that disperse in a medium, such as continuous gases, liquid or solid medium. The particles can be a large molecule, but it must remain dispersed indefinitely. The molecules could be proteins, solid, liquid or even gases. However, the particle size of colloid is larger than solution but smaller than suspension, thus it is called colloid. There is a colloid hand sanitizer called silver colloid hand sanitizer. This colloid hand sanitizer is a dispersed system. Dispersed system consists of two separate phases, an internal phase and continuous phase. In the silver colloid hand sanitizer, the internal phase will be the solvent and the continuous phase is the silver itself. It can be formulated as a runny liquid, Hence, it is a Newtonian type of flow. It also can be formulated as a gel that has non-Newtonian behavior as pseudoplastic fluid. What about suspension and emulsion dosage form? From my research, there is no hand sanitizer formulated in the dosage form of a suspension or emulsion. First, suspension. Pharmaceutical suspension are liquid dosage types consisting finely segregated insoluble compound, somewhat evenly dispersed in the suspension medium in which the compound shows a minimum degree of solubility. Since most of the hand sanitizer is an alcohol-based hand sanitizer, ethanol is known as universal solvent. Thus, it can dissolve all compound, either it is polar, non-polar, hydrophilic, or even hydrophobic. Hence, all the ingredients that used in the formulation of a hand sanitizer is soluble in the alcohol. Even if there is no usage of alcohol, I believe that hand sanitizer is not suitable to be formulated in suspension dosage form. It is because it will produce discomfort when using the hand sanitizer. Most of the suspension particles is in the form of solid or crystal. If it is applied to the skin, it can be so rough for the skin and potentially cause irritation. As for emulsion, the rheological properties are one of the reasons that emulsion is not suitable to be formulated as a hand sanitizer. Most emulsion exhibited non-Newtonian behavior, thus it can be either pseudoplastic fluid or plastic fluid. There will be a problem if hand sanitizer is formulated as a pseudoplastic fluid emulsion. When the shear stress is reduced, the flowability decreases, meanwhile the viscosity increases. This results in retarded creaming of emulsion droplet, especially if the density between the internal phase and the external phase is quite large. On the other hand, if the emulsion is formulated with plastic fluid characteristic, it must be concentrated emulsion. The interaction between the compound is stronger, hence it prevents the movement of the flow of the external phase. In conclusion, I suggest that a gel dosage form is the ideal type of hand sanitizer dosage form. It has a lot of advantages compared to the other type of dosage form. For example, it has a lower evaporation rate of alcohol. Therefore, the usage of alcohol in the hand sanitizer could be optimized in killing pathogens on the hands. The gel form of hand sanitizer also is very easy to apply on the hands because lesser spillage occurs. Due to the semi-solid and gel-like structure, the application of the hand sanitizer will not be sloppy. Other than that, the non-Newtonian behavior, pseudoplastic fluid, of a gel is an advantage to the formulation that avoid the spillage issue. I guess that's all from me. Thank you for lending me your ears and have a good day. Bye!